So today we're going to talk about negative exponents. Some of you may remember this from intro. We talked about this, but let me remind you a little bit of how we get negative exponents and so forth. So first of all, if I have x to the second power, what does that mean? Yeah, that's correct. What about x to the first power? Yeah, just x. Now you see what I'm doing? I am decreasing the exponent by 1. Okay, does anybody see what's happening from previous to the next as I decrease the exponent? What are we doing? What operation are we doing to get to the next? Yes, sir. We're dividing by what? X, the base, right? You see the base of this exponent is the x. We're dividing by x. So anybody want to guess what we're doing as we decrease? See, we had x to the second, x to the first, x is 0. As we decrease by 1, what do we need to do to x so that we get the number next to this? Yes, Savannah? Divide by x. Class, what's x divided by x?
0. I won.
Okay, don't say 0 because that's how you get it wrong. People see the exponent 0 and they think it's 0. Do I mean x times 0? No. Be careful. Okay, a lot of times people think it's 0. Now, guess what we're going to do then as we go on? Subtract 1 from 0, you get x to the negative 1, right, Shirab?
Right.
So then, what do you think I'm going to do from 1? See, x to 0 was 1. What do you think I'm going to do to 1 so that I get x?
By x?
What do you get then? If you 1 divided by x, what is that?
Negative
1 divided by x is negative 1?
1. 1 divided by x?
Yeah, what's that?
1 over x?
Yeah, that's the answer, guys. So this is the reason why, okay, you get x to the negative 1 power means 1 over x. Guess what then? Could we go more? What do you think x to the negative 2 will be? Andrew? So I'm dividing 1 over x by x. What does it mean when you divide by x? It's the same thing as multiplying by 1 over x, right? So what's 1 over x times 1 over x?
2 over x?
Nope.
1 over x, right?
That's fine. So you get 1 over x squared. So you could, if you want, you could write 1 over x to the first for that one. So really, does this negative exponent make this number negative or positive?
No.
No, it doesn't do anything like that. They think it does because you see the negative. Just like they see 0, you know, you don't multiply x times 0 and get 0. Does that make sense? So the negative exponent does not make the number negative or positive. All it does is what? It becomes 1 over what you had before, right? Without negative exponents. Does that make sense? You get this, guys? So let me show you what's happening here. From going from x squared to x, I am dividing by x. What's another way of writing dividing by x? Could I write multiplication as a multiplication? I am multiplying this by what, guys? 1 over x. Isn't that right? X times 1 over x. Doesn't that give you x? Same thing here. I'm multiplying by 1 over x. From here to here, I am multiplying by 1 over x, right? Here to here, I am multiplying by 1 over x. You get the idea? So if this is true, then what x to the negative nth power will be? Who could tell me then what this becomes? One person, 2, 3, 4, 5, 6. Lara, what do you think? 1 over x to the power of n. That's correct. How many people thought that this was 1 over x? Very good. Can I write it this way? 1 over xn? No. That's x times n. That's wrong, right? This is x to the nth power. Correct? Does this make sense? Yes? So knowing this, then, can you simplify x to the negative 7th power? By the way, isn't x to the negative 7th power, isn't that already simplified?
Oh.
Why not? Yes, Talene? Yeah, it turns out you cannot have negative on the exponent. Then it's not really totally simplified. So how do we write this then? Okay, John?
1 over x.
That's correct. It is 1 over x to the 7. Okay? Any question? Are we good? Does this make sense? Okay. What I'm going to do now is I'm going to kind of review a little bit of some of the rules of exponents, because do you think you're going to be dealing with exponents for homework tonight? let me see if you guys remember. You know when we gave you the rules for exponents, did we say anything about exponent being positive every time? Do they have to be positive every time? The answer is no. So it turns out all the rules that we learned, like the one that looks something like this. Who remembers this rule? If I have x to the m times x to the n, raise your hand if you, Chanzu? I have to add the exponents. Now, we did this when m and n were always positive, but turns out, guess what? Could you have negative exponents? It'll be the same rule, okay? You apply the same rule. So for example, go ahead, what do you think this becomes? Everybody think about this. Try it. So what I'm trying to show you is that all those rules we learned, they work for negative exponents also. So Alwyn, what do you think I get?
Could you go up like once you see
There's nothing up.
just rules for exponents?
Do we solve this? Is this an equation? No, we're simplifying right now. So who could tell me what to do? How about Aaron?
You do 3 plus -5.
Right. Well, 2 to the. Is that what? Yeah, 2 to 2, and then the exponent, right? Which is -2, isn't that right?
Yes.
3 plus -5. Yeah, I should have written down that work. I forgot. Sorry. So what is then? Can I leave it this way? No, that's not simplified. It just means 1 over 2 to the second. So no, it doesn't mean 4. It's 1. It means 1 over 4. Okay.
Yes.
So as you can see, the rules that we learned, right? It gives you. It works the same exactly, same way even with negative exponents. So, do you guys remember this? X to the m divided by x to the n, which is the same as writing x to the m over x to the n, right? Who remembers what to do when you have the same base again? By the way, is it important to have the same base?
Yes.
To rule, yeah. If you don't have same base, you can't use this rule. Judy, what do you think? You subtract the exponents. So you think you could do this one here? One with a negative exponent. 6 to the -3 divided by 6 to the 7th. Again, this just means 6 to the -3 over 6 to the 7th. Okay, same rule apply for negative exponents, okay? Same rules. So, Elizabeth, what do you think I get? Okay. But take a look at what we have. We have 6 to the -3 over 6 to the 7th. What do we do with the exponents? Okay, Elizabeth, we have this rule, right? When you have x to the m over x to the n, what do we do with the exponents? So guess what we're going to do with -6 and 7? I mean -3 and 7. Yeah, so you get 6 to the 4. Why? That's right. -3 minus -7. Isn't that 6 to the -10? Okay, and Elizabeth, can I leave it as 6 to the -10? You got it. Okay? Does that make sense? Go ahead, Elizabeth, I'll give you time to now write it down. Okay. So then what about this? You guys remember this rule? X to the m, the whole thing to the nth, raise your hand. What's the rule for this? Rules for exponents. Yes, Madeline? That's right. So you get x to the mn. So do you think it'll work for negative exponents as well? Yes. If I have 2 to the 3rd to the -2nd power, what do we get here? By the way, somebody asked, do I multiply 6 10 times for the other one? No, you don't need to do that, right? If it's too big. But for this one, I think you could do it, right? What do you get? 2 to the -6. Could I leave it as 2 to the -6? No. So this means really 2 to the, 1 over 2 to the 6. Should I leave it, or is this something we can multiply? This is not bad, right? Like 6 to the 10th, you should leave it, it's fine. But so what do you get? Who thinks they have the answer? Yes? 1 over 16? Are you sure?
No.
Okay. 2 to the 6 means 2 times 2 times 2. You multiply 6. Shh. Talene. 1 over 64 is correct. Because 2 to the 6 is 2 to the 3rd times 2 to the 3rd, right? Which is 8 times 8. Okay. Be careful. Yeah, even though these are pretty straightforward, sometimes you can make silly mistakes. Okay. Any question? So Matthew, what do I get for this ab to the n power?
You get a to the m power times b to the m power.
That's right. So, do you think it'll still this rule will still apply for with negative exponents?
No.
Expressions with negative exponents? Yes. So if I have 3x in quantity to the negative 2 power, Andrew, what does that become?
Becomes 3x. 3. Wait, hold on. Becomes
It means what?
3 to the negative 2
Good.
power
Times.
times x to the negative
Very. That's correct. That's what I'm looking for, right? Just like that, right? Just like the rules I showed you. Just because you have negative, it doesn't mean it's different rule. It's same rule. Okay. So, but we don't want to leave it this way. Of course, 3 to the negative 2 power means what class? 1 over what?
1 over 9.
1 over 3 squared, which is 1 over 9, you're right. And of course, x to the negative 2 power, 1 over x squared. So it just simply becomes 1 over 9x squared. Okay? And this is, I think, the last rule. AB to the m. It's kind of similar to the one we had before. It means AB times AB, m of these, right? So, Kristen, what does this equal to? What is it equal to?
A to the m over b to the m.
Good. A to the m over b to the m. And again, the ones with negative exponents still works. Okay, so if I have 3/5 to whole thing to the negative second power, Christine, what does that become?
3 to the 3 to the negative 2 over 5 to the negative.
Yes, do you all agree? Right, guys? Of course, we can't leave it this way. This is not simplified. So then, anybody know what to do? What does, Malia, what's 3 to the negative 2 power mean? Yeah, 1 over 3 squared. So I write it that way. And over, right, is over. Kyle, what does 5 to the negative 2 power mean? What does it mean?
5 to the second power over 1.
Yeah, say it again.
5 to the second power over 1.
Not quite. 5 to negative second power is equal to, just like if I had 3 to the negative 2, isn't it 1 over 3 to the second? So what do you think 5 to the negative 2 power is equal to?
5 to the second power
Under 1? No, just
over
1 over. There you go.
There you go.
There you go. Now, is this, okay, so could I just simplify it this way? 1 over 9 over 1 over 25?
Yeah.
Am I done?
No.
No. Okay, so this is okay to do, but then you can't leave it that way because for fractions, you don't want to leave, the numerators or denominators shouldn't be fractions or decimals. So what do? What does this mean?
Oh,
Yeah,
it's 1 over 9 divided by 1 over 25.
that's right. Lara, if I have 1 over 9 divided by 1 over 25, how do we rewrite this?
1 over 9 multiplied by 25.
Good. You write it as the reciprocal, and the answer is, how many people got 25 over 9? Raise your hand. Okay, if you didn't, take a look at it, fix your mistake. Very good. Most of you got it. Very good. Yes, go ahead. What'd you say?
3 to the negative second over 5 to the negative second.
I get it.
Can you just flip it and then have
Okay, so some of you okay. So I'm going to show you a nice shortcut that you should be aware of, okay? Yeah, hold on. No, you should know why this works this way first, okay? Hold on, let me show you the shortcut. Very good. Guys, this is a shortcut that you should really be aware of. Cameron just said it. If I have AB, this fraction to the negative 1 power, Matthew, well, what do you think this becomes, Matthew? Any idea?
1 over A and over 1 over B.
Yes. So it turns out that is this, B over A.
Oh, yeah.
In other words, what do we call this? This is the,
Shortcut.
well, yeah, but reciprocal of, thank you, Derek, is the reciprocal of A over B. So it turns out if you have a fraction, or actually just a number too, right? What was x to the negative 1 power mean? What does it mean? X to the negative 1 power means, yeah? 1 over x. Aren't they reciprocal of each other?
Yeah.
The same thing works for the fraction, right? If you have something to the negative 1 power, it gives you the reciprocal every time. Does that make sense? So it works for the fraction too. And actually, Matthew told us why. The reason why is because, just like he said, it's because AB to the negative 1 power means 1 over A over B, right? Right? Which means 1 divided by A over B, which means B over A, which is the reciprocal of A over B. So this is a nice shortcut that you should be aware of. Okay? So anything to the negative 1 power, guess what? It gives you the reciprocal. Okay? Good. Okay, so some of you wanted to practice. Let's practice on the one that we just did. Try. We had 3 over 5 to the negative 2 power. Well, we don't have to the negative 1 power now. Uh-oh. So I guess we can't use the shortcut. There's a nice way to actually rewrite this using the negative 1 power. Anybody need to see how? Yeah.
You can just, like, put the 3 to the negative 2 over 5 to the negative 2 and then do the reciprocal?
Not quite. What I'm saying is, we just learned this shortcut, right? AB to the negative 1 power, right? Anything to the negative 1 power is reciprocal. We don't have negative 1. Now we have negative 2. As a matter of fact, this is the one we just did, right?
Yes.
Is there a way to use this shortcut somehow? Use negative 1 power? Lindsay?
Is it -1 times 2?
That's right. Did you hear what she said?
Yes.
Negative 2 is really negative 1 times 2, right? So could we rewrite it this way? 3 to the 5th to the negative 1, the whole thing to the second power. Using the rule we just learned, right, Aaron?
Yes.
Negative 1 times 2 is negative 2, right? Why do we want to do it this way? Because we know that 3 to the 5th to the negative 1 power is what, class? 5 over 3. And 5 over 3, of course, to the second power, right? And of course, this is the same exact answer as we got before. Yes?
Why couldn't we just do 3 to the negative, when we got 3 to the negative second over 5 to the negative second, just flip it?
Because there's no rule that tells you that you could just flip them.
There has to be a reason.
Okay? Yeah, there has to be a reason why as to why. Okay.
But if you get the same
Does that make sense, Celine? The reason why you're flipping it is because of this, not because you have 3 to the negative 2 over 5 to the negative 2.
can we make
I mean, it kind of is like that, but
You're gonna get that answer.
yeah, I know, but you have to know why that works. You know what I mean? This is the reason. It's because it's something to the negative 1 power. Okay, let's see whether we really understood this. Okay, so I'm going to combine some of these rules together. Try example 1. Knowing what we just learned, go ahead and see if you could simplify all these. Go ahead, I'll give you some time. So, first of all, Elizabeth, I got 4 to the, really, this is 4 to the first power, isn't it? 4 to the first power over 4 to the negative 3. What do you do with the exponents when they're dividing? When the same expressions with the same base, when the two expressions with same base are dividing? What do we do with the exponents? So you get what? 4 to the? It's 4 to the first over 4 to the negative 3. So you do 4 to the 1 minus negative 3. Isn't that what you do? What do you get? What is 1 minus negative 3? Isn't that what we have here? What do you get? Using the definition of subtraction, this is same as 1 plus, which is, what? Yeah, it's 4 to the 4th, right? Okay, guys, which is 156? Right? Okay? Let's look at B. 8 to the 3rd times 8 to the negative 2. What do we do with the exponents for the numerators? Numerator. You add them. Don't you get then, Elizabeth, what did you get on this one? On the numerator, 8 to the 3rd plus negative 2, that's 8 to the? Good, over 8 to the? 4th. So don't we subtract them? 1 minus 4, which is class? So can I leave it as 8 to the negative 3? The answer is 1 over 512, or 1 over 8 to the 3rd. Okay. By the way, did anybody put down 5 to the 0 power as 0? Thank you, because they'll be wrong. What's 5 to the 0, class?
1.
Anything to the 0 power is?
1.
1, except 0 to the 0. That's undefined. Okay, but anything to the 0 except 1 is 1. So this is what you get, and isn't that same as 2 to the first over 2 to the negative 2 power? The whole thing to the negative 4. So you subtract the exponents now, because again it's in division. So 1 minus negative 2 is what, class? So it's 3. Okay, good. I'm glad we know how to add here. So a 2 to the third to the negative 4th power, what is it?
2 to the power negative 12.
Thank you. Then, of course, it's 1 over 2 to the 12th power. You don't need to multiply that out. Okay, good. If you didn't get it, ask your group. Some of you wrote down 1 over 8 to the 3rd. Why are they equivalent? Oh, you wrote 8 to the 4th, I mean. Sorry. Why are they equivalent? What's 8, class? It's 2 to the 3rd, isn't it? Isn't 8 2 to the 3rd? What's 2 to the 3rd to the 4th? 2 to the 12th. They're equivalent. So if you got 1 over 8 to the 4th, it's the same thing. Okay, go ahead and try example 2 then. Now this time, what's the difference? Anybody see the difference? Charlene, what's the difference?
They're variables.
Okay, now we have some variables, correct? Okay, go ahead, try them now. So first A, you get y to the 5th, y to the 0. Y to the 0 is just 1. So you just get, no one wrote 0, right? So y to the 5th over y to the negative 2, well, we subtract the exponent. So it's going to be 5 minus negative 2 to the whole thing to the negative 3rd power. 5 minus negative 2 is the same as 5 plus 2. So you get 7. And so you get 1 over 21. Y to the 21 power. Okay, because you get y to the negative 21. Because I wanted to show you the whole thing at once. B. Again, a to the 0 is just 1. So you just get b to the negative 3rd over b to the negative 6 to the 4th power. Yes? A to the what? It's b. Yeah. So, yeah, b to the negative 3rd, not 8. B to the negative 3rd over b to the negative 6. Then what do we do with the exponents? We subtract. So when you do b to the negative 3 minus negative 6, that is simply b to the, what's negative 3 plus 6, guys? 3, b to the 3rd. So what's the b to the 3rd to the 4th? There's your answer. Okay. All right. How many people got both of these right? Raise your hand. Okay, because of time, we don't have time to do this, but quickly look at this. What's the difference? There's a parenthesis here, and here's no parenthesis, right?
Oh, the base.
So, yeah, the base is different. What's the base for A?
4 times 3.
Yeah, 12. What's the base for B?
3.
Okay, so you're going to get different answer here. Does that make sense?
Yes.
Okay, so please be careful when you see something like this, that they have a different base, okay?